Okay, so here's our battery problem. The lifetime L of a battery has a normal distribution with a mean of 18 and a standard deviation of 4. So that means that our battery is distributed normally, mean of 18 and a standard deviation of 4. And remember, basically there are specific method marks for actually detailing what your distribution is. So Alice's calculator requires 4 batteries. And will stop working if any one battery reaches the end of its lifetime. So, A, find the probability that a randomly selected battery will last longer than 16 hours. Right, so this is just one single battery. So that means that the probability that our battery life is greater than 16, well, we can just get that from the calculator by using our CD function. And that is 0.691462. Now, as we do this, let's think in terms of our bell curve. That's our bell curve. We have our mean in the middle, and our mean is 18 hours. So this is saying the probability of being over 16, which is all of this, we can see must be more than a half because this is a symmetrical distribution. And we can see that our answer is more than a half. So that makes sense. Okay, right. At the start of her exam, Alice puts 4 new batteries into her calculator. She's used the calculator for 16 hours. So we've got some extra information here. It's been used for 16 hours, but has another 4 hours of exams to sit. So this is where we realise that this is a conditional probability. So we want to know the probability that our calculator will not stop working for Alice's remaining exams. So that means the battery life has to be more than 20, and we've been told that it is already longer than 16. So as is conditional probability, I need the probability that it's more than 16 and the probability that it's more than 20. That's our intersection. And that is over the probability of the information I'm given, which is the battery life is already over 16. So again, let's go back to our bell curve. We've got 18 as our mean. And that means basically this time it's got to be more than 16, but it also has to be more than 20. So where is it more than 16 and more than 20? Well, that's only here. So that means it's the same thing as the probability that the battery life is more than 20 divided by the probability the battery life is more than 16. Okay, again, we can use our calculator for this. And that is 0.308537. And that's divided by 0.691462, which gives us 0.446296. Now, this was the point of contention. This is for one battery lasting more than 20 hours, given it lasted more than 16 hours already. So we want it for 4 batteries. So all for my calculator, also for her calculator to continue to perform, I need that to be true 4 times. So the probability is 0.446296, and I have to raise that to the power of 4, which is 0.03964. So a bit less than 4%. Okay, so now for C, we're going to show the probability that our calculator will not stop working for the remainder of the exams to 3 sig figures. Basically, and she's got 2 new batteries and 2 old batteries. So what do we need? Basically, we need the probability that the new batteries last 4 hours, and there's 2 of them. And then I've got to multiply that by the probability that her old batteries last 20 hours, given that they lasted 16 hours already, and there's 2 of those. So I'm using the probability. This is my probability from B. So I just multiply those two together and I get 0.199. Okay, so you can see she's gone from 4% when she has four original batteries. That's improved to nearly 20% by putting 2 new batteries into it. Okay, so now D. Arthur claims she believes that the lifetime of the batteries was more than 18 hours. She took a random sample of 20. So straight away, key word here is sample. So that means that our sample size is 20, and we have to come up with a hypothesis. So H0 is that the mean is 18 as we thought it was. Alternative, that the mean is greater than 18 because Alice believed that the lifeline of the batteries was more. So we've got a 1-tailed test, and what we need to do, we need to look at our batteries, but remember it's the bar over the top because this is a sample, a mean of the sample. So I've got, that's normally distributed with 18, and then my standard deviation is my standard deviation over the square root of n, which is 20. So remember, the thing in purple is the thing we're putting into the calculator. The thing in the distribution is the standard deviation squared. So now we're going to work out the probability that our sample life is more than 19.2, which was what we saw in the question. And that probability is equal to 0.089852, and just like we always do, 0.089852 is greater than 0.05, which is our significance level from the question. Therefore, we accept H0, and there is insufficient evidence to support the claim. Okay, now this question here about the batteries surviving, what happens, what would be the case if we said what's the probability that they won't survive? Well, let's think about it the other way. So if one battery out of our 4 it fails, then the calculator fails. So that would be, if we work out the probability that the battery life is less than 20 hours, given that it's already more than 16 hours. Well, how do we work that out? Again, we need an intersection. So that's the probability the battery is less than 20, and the probability the battery is more than 16. And we're going to divide that again by the given information, which is the probability the battery life is more than 16. So again, let's think about our bell curve. That's 18, that's our median, or our mean, or our mode, whatever we want. And we're going to mark our 16 and our 20. So our intersection, it has to be less than 20 and it has to be more than 16. So actually that is that strip in the middle. And remember, basically when we use the CD function on the calculator, we can put in a lower and an upper limit. So when we do that, that strip, the probability is 0.38292. And we divide it again by our answer from B, which is 0.691462. The probability that it's going to last longer than 16 hours. And that gives us a probability of 0.5537831. And this is that it fails before 20 hours. And hopefully you've noticed that 1 minus 0.5537831 is equal to 0.446 2096, which was the answer that it survives for more than 20 hours. Okay, hopefully that helps.